Hey guys, so I'm doing number 1 for homework 2, and all you have to do is fill in these blanks in each column, and the columns are pressure, volume, number of moles, and temperature, and they're given to you in ATMs, cubed, moles, and degrees Celsius. So before you can actually use the ideal gas law, which is PV equals nRT, you have to convert all of the units to stuff that you can put into the equation. So the pressure needs to be in kilopascals, and we have to change degrees Celsius to Kelvin. So I started with that because it's the easiest, and you just add 273 to each of the numbers that they give you. So it's 428, 155, and 348 for the ones that you're given. And then converting the ATMs to kilopascals, first I converted them to pascals, so you multiply 5 times 1.01 times 10 to the 5th, and then you divide that by 1,000 to give you kilopascals, or you can do the King Henry died thing. So then once you do the conversion, you get 505, 30.3, and 451.5 for these. And then you can start plugging stuff into the formula. So for the first one, you're looking at this row, and you're going to do the ideal gas law with this. So you've got pressure, you're looking for volume, you've got moles, R is the constant, and you've got the temperature now. So plugging that in, it looks like P is 505 times V, which we're solving for, equals 2, which is the number of moles, times the constant, which is 8.314, times the temperature, which is 428, and then you divide both sides by 505 to get volume by itself, and you get 14.09 liters. So you can plug that number into that little blank up there. Then for the next row, it gives you pressure, volume, you're looking for moles, you've got the constant and the temperature, so it looks like 30.3 times 2 equals N, which you're solving for, times the constant times temperature. So then you divide both sides by this part right here, and the 8.314 times 155 is equal to 1288.67, so that's why I wrote it like that. So you divide both sides to get N by itself, and that gives you N equals 0.047 moles. And then the next row, you're looking for the temperature in Celsius, but I wrote it as Kelvin. So it gives you the pressure, volume, moles, you've got the constant, and you're looking for T. So you've got 451.5 times 25 equals 2.01 times the constant, and T is the variable. So then you divide both sides by what is on the right side to get T by itself. And when you do that, I didn't write that, but you guys know what to do. You get 675.45 Kelvin, and then if you want to write it back in on this table, all you have to do is subtract 273 to get it into Celsius, because if you write it in the table, it has to be Celsius, because that's what it gives you right there. And then for the last one, you're looking for P, so it gives you volume, moles, the constant, and temperature. Plugging those in, it's P times 2.25 equals 10.5 times the constant times the temperature, and then you divide both sides by 2.25 to get P by itself, and so P equals 13,501.94 kilopascals. And then again, if you wanted to plug it back into the little blank that they gave you, then you'd need to convert it back to ATM with the conversion. 1 ATM equals 1.01 times 10 to the 5th pascals. So you just have to convert it back, but this is technically the right answer too. So yeah, pretty much all you do is you work through each line solving for the missing variable, and make sure you pay close attention to the units that you're given.